Hey everyone, welcome to another session of CeerazzleDazzlePhysics. In today's session, we're looking at the derivation of the formula Rt is equal to R1 plus R2 plus dot 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 R to the N, which is the formula used to combine resistors when they're connected in series, and proof of the formula 1 over Rt is equal to 1 over R1 plus 1 over R2 dot 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 1 over R to the N, which is the formula used when combining resistors which are connected in parallel, guys. Okay, so quite a lot to take in. Before we get started, do make sure you hit the like and subscribe button to keep my channel going and keep all my content as free as possible. So let's get straight into it with the following diagram. Oh, and one more thing, make sure you fully understand GCSE physics, the electricity topic, because you need that understanding for this unit over here. So make sure you understand that before looking at it. Right, so first of all, over here you can see that we're going to be trying to combine resistors in series. Okay, so from here, first of all, we can do the following. We know that there's a voltage total going in, and that will be shared across each one of these. So the voltage across the first one, and V2, and V3. We can get an expression linking the voltage total and V1, V2, V3 by using, obviously, Kirchoff's first law, which states that the sum of the voltage in will be equal to the sum of the voltage out in one loop, guys. So in one loop. Okay, so for this one over here, so obviously the voltage going in is Vt, and the voltage coming out is going to be the addition of V1 plus V2 plus V3. So it's going to be over here, V1 plus V2 plus V3 over here. There we go. Okay, so from here we know that Ohm's law will be obeyed for V1, V2 and V3. So if you've forgotten what Ohm's law is, we know that the voltage will be equal to the current multiplied by the resistance. That will be true for each of those resistors. So I'm going to replace V1, V2 and V3 with the Ohm's law bit over here. So it becomes, have a look, the current in number 1, resistor 1, times by the resistance of 1. So let's call this one R1 over here. This one is R2, resistor 2. This one is resistor 3 over here. So there we go. I1 times by R1 plus the voltage of the second one will be the current going through the second resistor times by the resistance of the second resistor plus the current through the third resistor, I3, times by R3. Here we go over here. And that will be equal to the current total, IT, times by RT over here. Wonderful. So here we go. So now we've got this expression. Okay, so from here we can also find an expression to link the currents. We know that the current going through here, the current obviously going IT, the current going through this bit over here, is the same as the current going through all three of them. Because it's a series circuit, the current is the same everywhere. So we know the current going through the terminal over here, IT, will be equal to I1, which is the same as I2, which is the same as I3, because it's a series circuit. So hopefully we remember that in a series circuit, the current is the same everywhere in the loop. Okay, so from here, guys, we can say that I1, I2, and I3 are going to be the same as IT. So look what happens in terms of mathematics. IT, RT, will be equal to IT, R1, next one, plus IT R2 plus IT R3. Wonderful. So there we go, guys. We've got this expression now because the current is the same everywhere. And then, guys, we can use a little bit of mathematics. We can then factorize the IT out. So therefore, this part left-hand side becomes this. And the right-hand side, IT, open bracket, R1 plus R2 plus R3 over here. Wonderful. There we go. Now from here, guys, what can we do? We can actually cancel out the i's and we end up with the final expression, which is proving our formula that when you add resistors in series, the resistance in total will be equal to R1 plus R2 plus R3. There we go. And we'll put dot 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 R to the N, because obviously if you keep adding n number of resistors, it will end up with the following expression. Superb stuff. So you probably saw that formula in GCSE physics, but now look, you can prove it using maths in A-level physics. Easy stuff here. Okay, so what about in parallel circuits? Let's scroll down. So what about parallel circuits? Okay, so guys, we're going to look at now combining resistors in parallel. So when we've combined resistors in parallel before, we know that there's a formula 1 over RT will be equal to 1 over R1 plus 1 over R2 dot dot dot, however many you have, 1 over r to the n. And today we're going to prove it. So here, guys, I've got another circuit. As you can see, they're now connected in parallel. So we have R1, R2, and R3 now connected in parallel. Let's talk about it then. Let's look at the current first of all. So first of all, we know that there'll be a current flowing through the battery over here, and it will enter this junction point over here, and it will split. So the current entering the junction will obviously split. Let's call the current going through here IT. So IT goes into the junction and it splits. So the current will then run through here, which will be, let's call this one I1. Second junction will be I2. Third junction is I3 over here. So there we go. I1, I2, and I3. Okay, so from here we know that Kirchoff's second law states that the sum of the current going in, equals to the sum of the current going out at the junction. So obviously at the junction. Make sure we understand that. So at the junction itself over here, the sum of the current going in is obviously going to be, in this point, so for this junction over here, we know the junction is right there. We know that IT goes in, and that will be equal to the addition of I1 plus I2 plus I3. I1 plus I2 plus I3. There we go over here. So we've got 3 of them now. We now add them all together to work at the total current going into the junction. Okay, so from here, we know that for each of these resistors, Ohm's law will still be obeyed. So because obviously they're fixed resistors. So we remember that the voltage is equal to the current times by the resistance for each one of them. So I'm going to replace this with obviously V and R now. So IT will be equal to VT over RT. That will be equal to V1 over R1 plus V2 over R2 plus V3 over R3. There we go, we've got the next one now. So Vt over Rt is equal to V1 over R1 plus V2 over R2 plus V3 over R3 from here. Right, we can look at something else also. What about Kirchoff's first law, which states that the voltage going in, so here's my voltage going in, Vt goes in, that will be equal to the voltage coming out in one loop. So let's say this is V1 over here, this one is V2, the voltage dropped across resistor 2, and the last one is the voltage dropped across resistor 3. Okay, so Kirchoff's first law states that the sum of the voltage going in, so we know that the sum of the voltage going in is equal to the sum of the voltage out in one loop. So this is for loop, each loop, guys, each loop. So look, Vt goes in, and look, this loop, as you can see, it must be dropped off across V1. There we go, we can see that. So the voltage going in, Vt, must be all dropped off across V1. So therefore, we know that Vt will be equal to V1. And we also know that the voltage Vt will be also equal to V2, because look, this is another loop. There we go. So Vt will be equal to V2 over here. So Vt is also equal to V2. And we also know that Vt is the same as, look, another loop over here, so V3. So the voltage drop across them all is going to be the same, yeah? GCSE physics. So we now know the voltage across each one is going to be the same because it's a parallel circuit. We can then replace it into the equation above. So now look, I'm going to replace V1, V2, and V3 with Vt. The expression becomes the following. So it becomes Vt over Rt is equal to Vt over R1 plus Vt over R2 plus Vt over R3. There we go. And then a little bit of algebra, guys. Obviously, you can factorize it out. So we're just going to pull out the Vt over here. So Vt comes out the bracket, open bracket, 1 over Rt, close bracket, is equal to Vt, and obviously factorizing it becomes 1 over R1 plus 1 over R2 plus 1 over R3 over here. Wonderful stuff. And last of all, guys, you can simply cancel out the Vt from both sides. We end up with the expression we were looking for earlier on. It's going to be 1 over Rt is equal to 1 over R1 plus 1 over R2 plus 1 over R3. But obviously, if you look at many other resistors connected in parallel, 1 over r to the n. And this is our last formula, guys. So here is our last formula. And that is really cool, guys, because now you can prove those two formulas by using the voltage and current rules. And obviously, all you need to prove it is the understanding of Kirchoff's first law and Kirchoff's second law. And we've been able to do it for both of them. Okay, so quick recap right from the top. Let's do this. Right, so today's title is going to be derivation of resistance in total is equal to R1 plus R2 dot 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 R to the n when adding resistors in series, and 1 over RT is equal to 1 over R1 plus 1 over R2 dot 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 1 over R to the n when adding resistors in parallel, guys, when adding them in parallel. So scrolling down, I proved it. First of all, I drew a simple series circuit. We looked at the voltage going in and the voltage going out. We then use Ohm's law and change those voltages into current and resistance values. And then I knew that the current will be the same everywhere. So I said IT is equal to I1, which is equal to I2, which is equal to I3. Then I plug that into there. I factorized it, and we were able to prove that RT is equal to R1 plus R2 plus R3 dot 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 R to the n. Easy stuff. Right, and then I went on to combining resistors in parallel. So obviously we know that the formula is going to be 1 over RT is equal to 1 over R1 plus 1 over R2 dot 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 1 over R to the n. I then drew this circuit here, and I looked at the current going into the junction and current going out. We know that the total current going into the junction will be equal to the addition of I1 plus I2 plus I3. Then from there, I rearranged this formula by plugging in V and R. So VT over RT goes into each one of them. And then from there, we then said that the voltage going in is equal to the voltage coming out in one loop. We looked at that for each one of them. We know that Vt is equal to V1 is equal to V2 is equal to V3. And then finally, we then replaced it into our formula over here. So look, the V's are now all the same. Pulled out the V, factorized it, and then we end up with the following expression when combining resistors in parallel. So 1 over RT plus 1 over R1 plus 1 over R2 dot 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 1 over R to the n has now been proven. And that's it for another session of CeerazzleDazzle Physics. See you next time. Make sure you like and subscribe, and good luck in your studies. Goodbye.